Alright, so here we are. Let's see, with problem 8. Frictionless planes, here and here. These are inclined at different angles, theta 1, theta 2, M1, M2. And we're supposed to find the tension in the cord when I guess this thing is sort of released. So let's move on, and here I've copied this. So colors. Okay, problem 8, of course. And so let's see, where are we going? So let's do a let's find forces on these puppies. So both are feeling gravity, right? M1G and M2G, naturally. There's a normal force on both of them. We'll call it N2, and we'll call that one N1. And then they both got tension from the cables. There's your tension, and there's your tension. So what kind of coordinate system do we want to use here? Let's do X here going uphill, and let's do X here going downhill, and Y, of course, Y. And then we've got this super convenient situation where if this one starts accelerating uphill, this one accelerates, hang on, let me make that a little bigger. This one accelerates downhill, and they're both the same, so they're both accelerating in the same direction. Okay, so moving right along, let's do the free body diagram for number 1. Let's see, here is our 1. Yeah, let's see. There we go. There's a normal force. We've got the tension there, and we have M1G. So first one, the second one, then we have tension, normal force, M1G cosine theta, and then of course M1G sine theta. Okay. So what we care about is, let's see, we've got the you know, in the y direction it doesn't accelerate. We could do a force balance there and find the normal force, but at the moment it looks like we probably don't need it. This is N1. So let's just stick with X for this one. So let's do sum of forces in the X direction here, which is going to equal M times A, right? So this is going to be tension, which comes up this way, minus M1G sine theta, G sine theta, equals MA. Oh, sorry, M1A. So let's go ahead and how do we want to do this? Let's solve for A. So A equals T divided by M1 minus G sine theta. Easy enough. All right, let's do a free body diagram for number 2 now. And if we can solve this for A, this one for A as well, then we should be able to slap them together and get something out for tension. So for number 2, we've got, here's our N2, which is an angle theta 2 off of vertical. And there is our M2G, and here is our tension. That's all. And X, Y. Okay. And then we're going to start here. N2, tension, and then here's our, so this one is going to be, this is going to be cosine, right? M2G cosine theta. And this one here is going to be M2G sine theta. So, again, we're going to, there we go, let's see. Sum of forces in the X direction is going to equal, and so X positive here, A positive going the same way. So M2A. And so the sum of forces there is M2G sine theta minus T equals M2A. And I've been bad. Everything over here, all these thetas were theta 1. Theta 1 for number 1, and then for number 2, we were doing theta 2. So got to watch out for your thetas here because it is 2 different angles. Okay, so here's our equation, and then we just do this. We get A equals, again, divide everything by M2, which is the same as over here, except slightly different, but the same. So A here is going to be, let's see, G sine theta 2 minus T over M2. Okay, so now we have this A and this A, which are equal. So we can say T over M1 minus G sine theta 1. That's equal to G sine theta 2 minus T over M2. And then we get, if we put these together, we get that, I'll tell you, let's scroll down just a little bit there. We get that T over M1 plus T over M2 equals G times sine theta 1 plus sine theta 2. And then, so if what we want to do there is to fix this, make it sort of pretty, we want to multiply this side by M2, or this, this fraction by M2 on top and bottom, and this one by M1 top and bottom. Then we can add these up and factor that out. So we can say T times M1 plus M2 over M1 M2 equals G times sine theta 1 plus sine theta 2. And finally, we wanted to find the tension, right? So I'm just going to collect and solve for tension. T equals, let's see, M1 M2 G times sine theta 1 plus sine theta 2 all over M1 plus M2. So that, which I'm boxing in purple now, is basically going to be your answer. A little complicated, but that's how you get it.